Hi, and welcome to this tutorial where we are going to create an interest rate tree, and we are going to calibrate it so it is arbitrage free. And then we are going to value a bond using this tree, and just make sure that this bond is arbitrage free. So let's get to it. So we have some data. We have the spot rates, and these spot rates you can find publicized, or you can derive them from zero coupon bonds. Okay, so we have some prices here, and I've just calculated the price of zeros. Okay, so these zeros, they have a future value of 100. So the par value equals 100. And the cash flow for the year is 100, and it's discounted using the 1-year spot rate. Okay, so that would be the first zero coupon bond you would either observe or derive from the spot rates. And we also have the 2-year spot rate. So that would use the 2-year spot rate, well, the 2-year bond, I would say. That would be discounted using the 2-year spot rate to the second power, okay? And the 3-year bond has a future value of 100, and we use the 3-year spot rate and take 1 plus the 3-year spot rate raised to the third power to get the present value, or the price of that zero coupon bond. Okay, so what do we do now? We have to apply a sigma. Okay, we have to kind of make an estimate of the dispersion of the interest rate process. This can be estimated by implied volatility in the option market, or historical volatility using a statistical model. Okay, here we just take it for granted. We have made another video of how you can estimate the sigma of an interest rate process. Okay, so let's get to the bond itself. Here are the payments for the bond. And you see that it's a 5% coupon bond. So after year 1, or during year 1, you get 5. In year 2, you get 5. And in year 3, you get the future value, the par value, plus the coupon. Okay, because it's a 3-year bond we're going to calculate the price of. Okay, so now we go to the interest rate tree. What we see here is that the implied future rate at time 0, it's equal to the spot rate, the 1-year spot rate. And it's coincidentally equal to the 1-year par rate. Okay, so this rate we do know, and this rate is what we would discount any cash flow in year 1 with to get the present value at time 0. Okay? So any cash flow and present value at time 1, we would use this interest rate to get the present value of time 0. Okay? But we do have an interest rate tree. So we have some dispersion. Okay? So this interest rate, it might go up or it might go down. And we assume the interest rate process is log normal. So if it goes down by 1 standard deviation. If it goes up by 1 standard deviation. But it shifts because the level in year 1, the implied future rate year 1 could be higher. So what we do is that we just take the lower rate here and find the lower rate times 2 standard deviations. So there, between the high rate and the low rate, there would be 2 standard deviations, right? So here you have the low rate times the exponential, that would be the number e raised to some power, and the power is 2 times the standard deviation. Okay? So this is just the low rate times e to the 2 times the standard deviation. Okay. And coincidentally, all of these interest rate nodes, they are 2 standard deviations apart. Okay? Which means that at year 2, the standard deviation high and low, like high and low, is the low rate times e to the 2 times 2 standard deviations. And that means that plus 2 standard deviations, we get to the even higher interest rate, right? So here you get this medium rate times e to the 2 times the standard deviation. You could also take the low rate times e to the 4 times standard deviation. That would give you the same result. Okay? And these interest rates are what you would discount the year 3 cash flows or present values to get the year 2 present value. Okay? And at year 3, as we have a year 3 bond, we have the cash flows from the bond. Okay? So, first we have to calibrate our interest rate tree. So how do we do that? Well, we know the 2-year, the times 0 into 1 year implied future rate. So what we need to do is to just price a 0 with our tree and make it equal to the market price of the 0. Okay, so these are the market prices of the zeros given the spot rates. Okay, so let's get to it. So now we have to value a bond here. So what's the idea behind the value? It's just to take the probability of an up move times the cash flow or the present value at that node and discount it using the discount rate for the node where you want the present value. And here you also get, at this point 2 or time 2, you also get the cash flow from the coupon payment. So that's really important to remember. Okay. So using this 3.644% interest rate, the present value of half times this and half times this plus the coupon, which is not discounted, would be 106.3081. Okay? We don't know if this is the correct interest rate because we have to calibrate our interest rate tree. Okay? So what we do then is that we know that the price of this zero is based on an interest rate of 2. This is our first step in the interest rate tree. However, we have just guessed the year 2 low rate and hence the high rate. Okay? So what we do is that we just imply a cash flow. We say that, well, we are going to price a bond with cash flow 100 at year 2 and 0 otherwise. So this is a 0 coupon bond. Okay? And we would like to get the present value of this bond equal to the present value of the bond observed in the market. Okay? And here we can see that our value is 95.7, but the observed market value for this kind of cash flow, okay, this kind of bond, is 94.23. So we know that our interest rate is too low. So let's try 3%. Okay. So now we have, with 3% and 4.050% in our interest rate tree, our cash flow at time 2 is priced as 94.7. Okay, so we see that this is much closer to the observed price in the market. However, we are going to use the numerical method, which just means basically we are guessing numbers in a systematic way. So now we have to use the solver in Excel. Okay, so here we have the solver, and what do we need to do? We have an objective, which is the value, okay, the present value of the bond. We want to set this to the value of 94.2321, right? By changing this cell, by changing the interest rate, right? And then we can just click solve, and we keep the solver solution, and we have a new down move if this interest rate has a down move of 3.442%, and hence a 2 standard deviation above that, a high move of 4.4646, then our 2-year zero coupon bond gets a value of 94.2321, which is coincidentally equal to the market price. Okay, so now we have calibrated the first step in our interest rate tree. So now we move on to the second step of our tree, which means that we need to use a 3-year zero coupon bond. We have the price of a 3-year zero coupon bond here, 88.75, and we would like our price here to be equal to the market price. If we can price this bond such that the model gives the same price as the market price, then we have calibrated our model, okay? Which means that we try to change this low interest rate until our market price is equal to, no, the model price is equal to the market price. So of course we don't want to just guess. We use a numerical method, which means that we set the objective, we set this cell equal to the value of 88.7587, okay? By changing cell, which is here, the interest rate. If you change this cell, you automatically change the other cells, the other interests of that period, because they are just interlinked by the standard deviation. Okay, and we click solve, and we keep the solver solution. So the down move is actually 4.483%, and this medium interest rate is just two standard deviations above this low rate, and this high rate is 4 standard deviations above the low rate. Okay, so let's see if we get the expected result. So here we got from the model, we priced a 3-year zero coupon bond at 88.7587, which is equal to the market price of the bond. Okay, so that's a very good result. So now we have calibrated our interest rate tree. Okay, which means that we can now value any 3-year bond with our interest rate tree. So for example, the 5% coupon 3-year bond, the price would be 102.8102, which is the correct result. But how do you know that 102.81 is the correct price? Well, then we just use the standard method, the discounting of the cash flow, to kind of calculate the present value of these cash flows in the classical way, which means that we just add these time values, and we're going to discount these. This is the year 2 cash flow, so we need to use the year 2 spot rate. And since it's year 2, we need to raise it to the second power. Okay? And we have the year 3 coupon plus face value. Okay? So we get 103 divided by the year 3 spot rate. Oh, sorry about that. The year 3 spot rate raised to the 3 power. Okay? Third power, that is. So, let's see. Just quickly get rid of some decimals. And we can just say this is the sum of these numbers. Okay? And coincidentally, the classical method gives us the same value as our tree. So now we know that our interest rate tree is actually arbitrage free.